Welcome back to the channel, bringing you the latest news from around the world. I bet you didn't know the moon still holds secrets we've never touched. Until now. In May 2024, China's Chang'e-6 lander descended toward the far side of the moon, a place no human had ever seen directly. The lander targeted the South Pole Aitken Basin, one of the oldest and largest impact craters in the solar system. With no direct line to Earth, Chang'e-6 relied on its own sensors to scan the rugged terrain, avoiding hazards as it hovered and adjusted its descent. Mission controllers in Beijing watched anxiously as data streamed in via a relay satellite. Then, touchdown, the lander settled softly onto the gray, untouched surface. For the first time, a machine was ready to collect and return samples from this mysterious lunar realm. Its mission: drill into the regolith, scoop up rocks and soil untouched for eons, and bring them home. These samples held clues to the moon's violent birth, volcanic past, and the stark differences between its two faces. Every previous lunar sample, from Apollo to Luna, came from the near side. The far side was a blank page. Did it form differently? Did it have a unique volcanic history? Chang'e-6 was built to find out. Its robotic arm extended, drill whirred, and humanity began to dig into the moon's deepest secrets. This was more than a landing, it was a leap into the unknown, rewriting what we know about our closest neighbor. The far side's silence was finally broken by the sound of discovery. When nearly 2 kilograms of lunar soil and rock returned to Earth, scientists were stunned by what they found. Among the dust were basalt fragments, proof that volcanoes once erupted on the moon's far side. The samples showed volcanic activity spanned at least 1.4 billion years, not just a brief event. This forced scientists to rethink how the moon's internal heat worked, suggesting a global phenomenon, not just a near-side story. Curiously, the far-side basalts lacked the radioactive elements that fueled near-side volcanism. One theory, the colossal impact that formed the South Pole Aitken Basin, thinned the crust, letting magma rise for eons. The far side wasn't a quiet bystander, it was geologically alive. These findings help explain why the moon's two faces are so different. The story of the moon is one of fire, impact, and a dynamic world on both sides. Chang'e-6's samples have redrawn the map of lunar history. The moon's far side is no longer a mystery, it's a vital chapter in our solar system's story. For decades, scientists believed the moon formed from a giant impact, creating a global ocean of molten rock. Chang'e-6's samples provided the strongest evidence yet. The far-side rocks shared the same basic chemistry as Apollo's near-side samples. This uniformity means the moon was once a well-mixed liquid world. As the magma ocean cooled, lighter minerals floated to form the crust, heavier ones sank to create the mantle. The differences between the near and far sides came later, shaped by impacts in volcanic history. The magma ocean theory is now near certain thanks to these new rocks. We can finally trace the moon's earliest moments, from fiery birth to solid world. Chang'e-6 has confirmed a critical chapter in lunar science. The moon's story is one of shared origins, not separate histories. While some discoveries confirmed old theories, one finding shocked scientists: the far side is almost bone dry. The mantle rocks from Chang'e-6 are the driest lunar material ever studied. Less than 2 micrograms of water per gram. That's 100 times drier than the near side. The moon, it turns out, has a wet side and a true desert. This challenges our models of how water was delivered to the Earth-Moon system. The likely reason: after the giant impact, the far side lost its water to space, while the near side, shielded by Earth, retained more. For future explorers, this means the far side is a poor place to look for water. Plans for lunar bases will focus on the wetter near side or the icy poles. The far side's beauty hides a barren truth: no water, just secrets. Chang'e-6's data is rewriting the moon's history. Long-lived volcanism on the far side shows the moon's internal engine was active everywhere, not just on the near side. The extreme dryness of the far side mantle explains why it's covered in bright, cratered highlands, not dark lava plains. The moon's two faces are a direct result of their different water content, a wet side and a dry side. The evidence for a global magma ocean and uneven water distribution gives scientists new rules for modeling the moon's origin. The South Pole Aitken impact didn't just scar the surface, it changed the deep mantle forever. The moon's story is now one of complexity, connection, and transformation. Chang'e-6 has given us a more complete biography of our nearest neighbor. Chang'e-6's discoveries are shaping the future of lunar exploration. Knowing where water is and isn't will guide where humans build outposts. The moon's south pole, rich in water ice, is now the prime target for future missions. China's next steps. Chang'e-7 will explore the South Pole and Chang'e-8 will test using lunar resources. The goal: an international lunar research station by 2035. The US and its Artemis partners are racing to the same region. The next decade will see a new era of discovery, competition, and collaboration on the moon. The first nation to harness lunar resources could lead humanity's expansion into space. The moon is our proving ground for life beyond Earth. The silent dust of the far side has spoken, guiding our next steps into the cosmos.